Hello everyone. Today we are going to start with next topic, that is force due to multiple charges, and yesterday we have discussed Coulomb's law of electrostatics, which tells us about the force between the 2 point charges when they are placed at some distance. And one very important thing, let me tell you about that law of Coulomb's law. The Coulomb's law is valid only when the charges are point in size and they are stationary. So this is the condition for the application of Coulomb's law. If the 2 charges are point size and they have to be stationary, only then we can apply Coulomb's law. Now let us come to the next topic. We are discussing electrostatics. And electrostatics chapter 1 we are discussing, that is electrode charges and fields. So next topic of our discussion is force due to multiple charges. So in order to find out the net force on a particular charge because of other charges present, let us consider one example here. Let us consider we are having this charge Q1 in our system, and we are having number of charges, other charges present in the system. Now let us consider we have different charges, that is Q2, Q3, Q4, Q5, Q6 and so on. Let us consider number of charges are there, and you see I want the distance also. Distance of all the charges from the charge on which I want to calculate the net force. So let us consider this is R12, R13, R14, R15 and R16. So all these distances I am having now, as per the nature of the charges, whether they are attractive or repulsive, we can consider that this charge is applying force, and we, for the simplicity, we are considering all the charges to be positive. So this is pushing this charge, another charge Q3. So this is what? This is the force on 1 due to 2. And another charge is pushing this. This is force on 1 due to 3. Q4 is pushing it. This is charge on 1 due to 4. This is also pushing it. This is charge on 1 due to 5. And this is 6. This is also pushing it. This is force on 1 due to 6. So all these charges, they are present in the system, and they are applying force on this small charge Q1, and we will find out the different forces acting on charge Q1, and then we can simply use the principle of superposition. What does it say? That net force on a charge present in the system due to other charges separately. We can find out the force due to other charges separately, and then we have to simply take the vector sum of all other forces to find out the resultant force. So mathematically, how we can write force on this particular charge is F net force. I'm writing F12 plus F13, F14, F15, F16 and so on if number of charges are more in the system. So this is the principle of superposition. Principle of superposition, what does it say? That suppose if we are finding the force on charge Q1 due to Q2, if other charge is present in the system, this force will not be affected by the presence of other charges in the system. So here what we can do, the principle of superposition. One thing I have told you that the presence of other charges is not going to affect the force on a particular charge due to the other charge. And the second thing, the net force on a charge because of other charges present in the system is vector sum of all the individual forces on that particular charge. So again, this is as per this also we have written this statement. So if I want to find out the resultant force on a particular charge, that would be the vector sum of all the forces taken separately due to other charges present in the system, and so on. So this is the principle of superposition. Something else. So let us consider any arbitrary values I am going to consider here. Let us consider the 3-point charges are placed at the 3 vertices of an equilateral triangle. Let us consider this is an equilateral triangle. And let us consider any arbitrary values. Let us consider. And if all the 3-point charges are, for example, equal, for example, this is simplest case I am taking, and suppose this point is A, this point is B, this point is C. ABC is an equilateral triangle, and the 3 equal charges in magnitude as well as their signs are also same. So all the 3 charges equal to Q, they are placed at the 3 vertices. Now let us consider, we want to find out the force on charge QA, which is placed at QA. So we want to find out the force on the charge which is placed at point A. So this I want to calculate. So I am putting vector here. I want to find out the magnitude as well as the direction also. So how we can start? We need to see how many other charges are present. One charge is present at B and other is present at C. So both of these charges are there to apply force on that particular charge. Now let's find out the force on charge at A due to B. So now let's find out. I'll write the magnitude first. So this, and let us one more thing we have missed here, the side of the equilateral triangle, let us consider that is A. That is also required. A distance is required. Without distance we can't write actual magnitude of the force. So let us consider this charge is applying force on this charge, and because both of them they are having the same sign, that is positive sign, so this charge is going to push this charge away from it. So this would be the direction of FAB. So I can write here. So this would be K times first charge is Q, second charge is Q, and the distance between them is A, that is A square. So this is the magnitude and direction I am drawing there. And similarly, other charge Q is also present there at point C. That is also there to apply force on charge at A. So because of that also I can find out the force on the charge placed at A due to C. That would be K Q over A square. And what would be the direction here? So this direction is also away from, because they are like charges. So this is force on A due to C. So direction of both of the forces is there with me, and I have written the magnitudes of both of the forces, and you can see both of the forces are equal in magnitude. So we can write this as K Q square over A square. This is also K Q square over A square. So we can write down both of the values as F. So two equal forces. Now we have to find out the resultant of these two forces. Can I write the angle between the two forces? Yes, because this triangle was equilateral triangle, and we know that the angle of equilateral triangle is 60 degree. So these two forces are inclined at an angle of 60 degree. So now I know the angle between the two, so I can simply find out the vector sum. The vector sum between the two forces. So F net, let us find out F net here. First I am writing the magnitude. So magnitude would be first force square FAB, that is F square. Second force square, that is FAC, that is also F square. Both of them they are F. Plus 2 FAB, F. Plus 2 FAC, that is also F. Cos of angle between the two forces, that is 60 degree. Now let us simplify this. F square plus F square plus 2F square cos 60 is 1 by 2. So this is F square plus F square plus F square. So this would become under root 3 F square. And this can be written as root 3 F. I am taking out of the root. So this is root 3 F. And so magnitude, if you want to write the magnitude properly, F's value you can write here. So this would become root 3 K Q square over A square. K's value you can always write in terms of epsilon. So this you can write under root 3 over 4 pi epsilon naught Q square over A square. So this is the magnitude of the resultant force on the charge which was placed at point A. Now direction also I want. So we know one more thing we have discussed in class 11th, that for two equal vectors, resultant is always towards the angle bisector of the two vectors. So resultant would be at 30 degree. That is without any proof I am writing here, but will prove also. Here you can write, if this is the net force, let us consider it is making an angle phi with one of the force, that is FAC. So let us find out the direction of the F net also. So direction is tan phi. With tan phi we can find out the direction. So that would be F sine theta over F, because both of the forces are F here, F plus F cos theta. Theta here is 60 degree. So F sine 60 over F plus F cos 60. So sine 60 is root 3 by 2, F root 3 by 2, F I am taking common from here, 1 plus cos 60 is 1 by 2. So F get cancelled, root 3 by 2 over 1 plus half, 3 by 2. So 2 cancels. So we are left with 3 over root 3 over 3, or it would be 1 by root 3. And when tangent of phi is 1 by root 3, when phi is, so here tan phi is 1 by root 3. So phi would be 30 degree. So you can write here that, you see we have done calculated both of the things. Here we have calculated the magnitude of the resultant force. Here we have calculated the direction of the resultant force. So this was a simple example we have discussed here, how we can find out the total force on a particular charge when number of charges are present in the system. So I am giving you one assignment here. The same thing you can calculate with the 4 charges when they are placed at the 4 vertices of a square of side A and 4 vertices of a rectangle of sides A and B. Similarly, same method you have to apply, and you can practice with the different amounts of the charges. You may take one Q, or you may take Q minus Q, Q and Q. Any of the combination of the charges you can take, and you can do your practice for finding the resultant force on a particular charge.